Okay, for this video, I want you to be able to represent, analyze, and solve combinations. Okay, and combinations are very similar to permutations, except for the biggest difference is the order. We say the order doesn't matter, or the order of the outcomes. If you have the same amount, the same result, but the arrangement is a little different, it's still counted as the same. I'll give you an example. Okay, so let's say there's the cafeteria has 20 different meals that they make, and then they just go through the same different 20 meals, and they pick the meals at random, but it's always from the grouping of 20. And let's say out of those 20 meals, you have a favorite five favorite meals that you have. And so we want to find the probability, or what is the likelihood that on a given week you're going to have the five meals that you like. Now, when we say the order doesn't matter, let's say you like hamburgers, taco rice, goya champuru, and two more, right? If you have taco rice on Monday and goya champuru on Wednesday, or you have goya champuru on Monday and taco rice on Wednesday, we're counting that as the same thing, that you're going to have your top five favorite meals during that week, okay? And so if you have taco rice on Monday or Tuesday or Wednesday, it doesn't really matter as long as some time during that week you're going to eat some taco rice. So how do we figure that out? Well, if this was a permutation, right, and they had 20 meals, then what we would do is we'd say 20 permutation 5. We're picking 5 out of those 20 meals, and then what would happen is we would solve this by doing 20 factorial over 20 minus 5 factorial, and we would get 15 factorial on the bottom, and we would get 20 times 19 times 18, 17, 16, 15 factorial, and then the 15s would cancel, and then we would figure that out to be, I didn't do it ahead of time, 20. Okay, it looks like it's going to be a really big number, obviously. 1860480. I think that's right. Anyway, 1 million something. So it's a big number. But that's a permutation. That's saying the order makes a difference. So if I have taco rice on Monday and then hamburger on Tuesday, that's different from hamburger on Monday and taco rice Tuesday. Well, if you remember that if let's assume that I do get my top 5 meals that I want, the ways that I could have my top 5 meals served Monday through Friday, if this was Monday and Tuesday, Wednesday, Thursday, Friday, well, I could have, there's 5 choices for the first day, right? Let me write it up here for the glare. 5 choices for the first day, then there's only 4 and 3 and 2 and 1. So there's 60 different ways that if I have all my top 5 during that week, there's 60 different ways that those could be served. Taco rice, hamburger, goya champuru, taco rice, hamburger, pizza, whatever it is. There's 60 different ways. So over here, if this was the total amount when the order does matter, but now I'm saying the order doesn't matter, and there's 60 different ways that order could be, and I'd still get the same meals, just in a different order, then I would divide that number by 60, and then I'm down to 31,008. That's how many, or it would be 1 out of this many would be the chance of me actually getting exactly what I want. But that's how many ways 5 different meals could be served during that week where the order doesn't matter. Now, there's a little bit, if I combine everything that I just said here and just kind of simplify it without doing the permutation, the other formula that you can do is this. is NCR, where the N, same problem, N is 20, that's the number of meals that's possible, and the R is 5, that's the number of meals that I'm, my 5 meals that I want. So now we would do 20C5, and then this is a kind of condensed, I think, or an easier version of doing this problem. So 20 factorial over 5 factorial times 20 minus 5 factorial. And again, this is going to arrive us at the same answer, just in a little bit different way. So 20 factorial is 20 times 19 times 18 times 17, 16, 15 factorial over 5 factorial times 15 factorial. So at this point, the 15 factorial could cancel, then I could plug that in, divided by that, and that will give me the same 31.08, the same answer I had before. Or, of course, I think all of you know that if you have a scientific calculator and you have this button, then you can just put it in straight that way. So let me give you a few more examples of where you might see this combination, right? Again, the order does not matter. Well, let's say, I think I used this in the previous video, I'm ordering a pizza, and I want, there's a total of 10 toppings, and I want to get 3 toppings on my pizza. And of course, I don't care if they put the pepperoni on first, and then the sausage, and then the black olives, or if they put the black olives on first and the pepperoni. It's going to be the same pizza. It's all going to go on my mouth. So I can do 10 factorial, 3 factorial, 10 minus 3 factorial. That gives me 10, 9, 8, 7. Right? So you can see that these 7 factorials cancel. 3 factorial, if I want to go this route, I can say 10 times 9 times 8, and then 3 times 2. I'm not going to write times 1, but it would be times 1, right? Times 1, we can just assume that it's times 1 is this 3 factorial. Well, this 3, now watch this simplifying for you, right? This 3 and this 9 can cancel to 3 and 1. You guys know how to do that, simplifying fractions? This 8 and this 2 can cancel to a 4. So now I have 10 times 3 is 30, times 4 is 120, and you can do that math without a calculator. So there's 120 different ways that you could have 3 different toppings out of 10 on a pizza, and the order in which you put the toppings does not matter. Okay, last but not least, let's say I'm designing a shirt, and the choices of colors, there's 5 choices of color print that I want, and I need to pick 2 colors out of the 5 choices, right? And it doesn't matter if I pick green and red or red and green, it's going to be the same 2 colors. So 5 combination 2, I'll do 5 factorial on top, 2 factorial, 5 minus 2 factorial gives me 3 factorial. Don't forget that 2. Okay. 5 times 4 times 3 factorial, 2 factorial times 3 factorial. That cancels, and I get 5 times 4 over 2 factorial, and 2 times 2 factorial is 2 times 1. You can cancel that 1 and that 2, and I'm left with 10. So if I have 10 choices, 5 choices, and I need to pick 2 different colors, there's 10 different color combinations that I can choose. Again, if the order doesn't matter. So anyway, that is combinations in a nutshell. Very easy to get them to do the math, although it's a little bit tricky to remember or to figure out, hey, is this a problem that the order matters, or is this a problem that the order doesn't really matter? And so you would need to know that in order to figure out if it's going to be a combination or a permutation. Again, hope this doesn't get too confusing, but Just as a last note, it's interesting that a combination lock is not really a combination. In fact, truth be told, I used to say that a combination lock is a permutation, but it's not even really a permutation because there's a permutation would indicate that you have however many choices for the first number, and then you would have one less choices for the second number. That's not really the case. If you have one of those twist locks where you have 10 numbers, 0 and then 1 through 9, then your second number, if it can repeat, you'd do 10 times 10, and then if there was 3 numbers, it would be 10 times 10 times 10. So it's not even really a permutation either. But anyway, that's another topic for another day. Hope this makes sense, and thank you for watching.